At the reciprocal function, one of the most important functions that you'll learn in algebra. So the reciprocal function is going to be f of x equals 1 over x. F of x equals 1 over x. There we go. So this function is only defined if x is not 0. That's the first thing I want to say about it. Because if x really does equal 0, then you'll actually have a 0 in the denominator, and you will be dividing 1 by 0, which is technically undefined. So we can't even actually allow that to happen. But what we're going to do with this reciprocal function is we're going to analyze it just like we would any other rational function. And rational functions can be factored, common factors can be canceled out, and we can find several characteristics that are important to mention. Like, what are the function's zeros? Or x-intercepts, as they say. What are the zeros? Also known as the x-intercepts. We can also find out what the vertical asymptotes are going to be. What about horizontal asymptotes? And we can also find if there are any oblique asymptotes and point discontinuities. So with this function, we're going to start off with zeros, and then we're going to work our way down, and we're going to figure out all 5 of these. So for the zeros, we're really looking at where this function crosses the x-axis. And the way we find those is we set the top of the fraction equal to 0. Well, the top of the fraction is 1, so if I set 1 equal to 0, then I have a false statement. So therefore, 1 is not equal to 0, so there are no zeros, or no x-intercepts. Same thing. Okay, so we can also find asymptotes. Now, there are 3 different types of asymptotes. There are vertical, horizontal, and slant, also known as oblique asymptotes. If you want to find the vertical asymptotes, what you want to do for those is set the bottom equal to 0. So if I set the bottom equal to 0, I get x equals 0, and that is my vertical asymptote. Moving right along, we reach horizontal asymptotes. We want to compare the top degree and the bottom degree. So what's the degree of 1, which is the top, and what is the degree of the bottom, which is x? Well, we know that the degree of any real number is going to be 0. We're really looking at the highest exponent, and since there's no x's, then there's not going to be any exponents. That's pretty logical. And if you look at the degree of x, the highest exponent will be 1. So the degree of x is just 1. So now you have a situation where you want to compare the two numbers, and you have 0 is less than 1. So this is less than this. If you have this type of situation where the top degree is smaller than the bottom degree, your horizontal asymptote is always going to be y equals 0, also known as the x-axis. Okay, oblique asymptotes are next. Those only happen when the degree of the top is equal to 1 plus the degree of the bottom. Okay, so let's think this through. We know that the degree of the top is still 0. We know that the degree of the bottom is in fact 1. So I have 0 equals 1 plus 1. That doesn't work because that gives us 0 equals 2. So these two sides are unequal. So I'm going to put a not equal to sign. So since these two sides are not equal, there are no oblique asymptotes. So I'm just going to write none. Now for point discontinuities, you really only have those if you have canceled out factors. So do we have canceled out factors? Do we have any that we canceled out? No. Not with 1 over x. So since we don't have that, we can say that there are no point discontinuities at all. So there are none. Okay? Let's hop on over to Desmos and let's see if we can verify all this information. So I'm going to move on over to Desmos, and what I want to do is I want to graph f of x equals 1 over x. So I'm going to do that over on the left side, I get f of x is equal to 1 over x. Now, we said that there are no x-intercepts, and true to form, there are none, right? This graph does not cross the x-axis at all, so there are no zeros, no x-intercepts, right? What about the vertical asymptotes? Well, we know from the slide that our vertical asymptote was 0, x equals 0, so I'm going to take the time to graph that. X equals 0. I get a vertical line, which is pretty much the same thing as the y-axis. What I'm going to do with this is I'm going to change it to a dotted line, and now it's a true asymptote. Notice that the graph gets closer and closer to this y-axis, but never actually crosses, which is pretty amazing. But that's just what happens when you divide by 0. Now let's graph the horizontal asymptote. Now if you remember from the slide, our horizontal asymptote was y equals 0. We're going to graph that, y equals 0. Okay, we get the x-axis. That's pretty neat. I'm going to make this a dotted line. And now what you'll notice when I zoom in is that the graph gets closer and closer to the x-axis, but it will never actually cross the x-axis, which explains why we have no zeros. And since there are no oblique asymptotes, I don't have to graph those, and since there are no point discontinuities, I don't have to worry about those either. So that's the reciprocal function, and I hope that helps.